Hi, my name is Damon Joels, and today I'll be looking at question 6 from paper 2 of the 2020 external exam. Question 6. A company needs to complete the following project as quickly as possible. Each task can only be completed by a single employee and must be completed before the employee can start the next task. The owner believes that this project can be completed in minimal time with only 3 employees. Evaluate the reasonableness of this belief. So the first thing we need to do is we need to draw up an activity network. So I've pre-prepared the circles here for the activity network, because in order to draw an activity network, we need to do a forward scanning and then we need to do a backward scanning in order to work out the minimum completion time of the network. So in terms of doing the forward scanning, we need to break these circles in half in order to do a forward scan and a backward scan. So what we'll do is I'll break these ones in half and then we will conduct our forward scan. Okay, to start off with, we know that activity A, its duration is 3 days. Okay, so what we'll do is we'll connect these two here. Okay, we'll call this activity A, and that's 3 days. Activity B, it is 4 days. So from this network here, we'll connect this one here. That is activity B, and that is going to take 4 days. Activity C has A as a prerequisite. Okay, so we will connect these ones here. We'll call that activity C, and the completion time is 2 days. Okay, so we'll make that 2. Activity F and activity G both have B as an immediate predecessor. So we'll connect this one here. Okay, we'll make this one here activity F. It is 4 days. So F, 4. And we'll make this one here activity G. Okay, and activity G, its duration was 3 days. Okay, we've got activity E. Its immediate predecessor was activity C. So we'll connect these ones up here. Okay, we'll call this activity E, and its duration was 5 days. Okay, we've got activity H's immediate predecessor was E and F. Okay, so what we'll do is we'll connect this one up here. We'll make this activity H, and its duration was 1 day. We've got activity I. Its immediate predecessor was activity G. Okay, and activity I, its duration was 2 days. And then we've got activity J, its immediate predecessor was H. So we'll connect these ones up here. So that one there, that is activity J, it is 3 days. And we also had activity D, its immediate predecessor was activity C. So we've got this one here, we'll put that one in there. Okay, and that's activity D. So we've got activity D, and its duration was 8 days. So that's what our activity network is going to look like. So now we need to do a forward scan. So remember, for the forward scan, we always start off with a 0 on the left-hand side. So the earliest start time is a 0. Remember, for our forward scan on the way across, we're always writing the largest number in the node. So 0 plus 3 is going to be a 3. There's only the one option, so 3 goes in the node. Going this way for activity B, so 0 plus 4 would be a 4. So there's only one option, so 4 goes in the node. We've got 3 plus 2, that will be 5. Okay, so 5 is going to go in the front there for the earliest start time. Down here we've got 4 plus 3 is 7. Okay, so we'll put a 7 inside the left-hand side of the node. Now, for the next option, we've got 2 options. So 4 plus 4, it could be an 8, or we've got 5 plus 5 could be a 10. And remember, we're writing the largest number in the left-hand side, so 10 goes in the left-hand side. 10 plus 1 could be 11 days, or 7 plus 2 could be 9 days. Out of 11 and 9, 11 is the largest, so 11 goes in the node there. 11 plus 3 is 14, or we've got 5 plus 8 across the top is 13. And remember, the largest number is going in the left-hand side. So the earliest start time for that node there would be 14. Therefore, the minimum completion time of this activity network is 14 days. However, we need to make sure we do a backward scan. So what we'll do is we'll change the color here. Remember, we always write a 14, the same number. And then on the way back for the backward scan, we're writing the smallest number on the way back. So we've got 14 subtract 3 could be an 11, and there's only one option. So 11 goes in the node there. We've got 11 take away 2, okay, which is 9. There's only the one option, so 9 goes in there. 11 take away 1 is a 10, and there is only the one option there, so 10 is going to go there. Now, we've got two options here. 10 take away 5 could be 5, or across the top, we've got 14 take away 8 could be 6. Remember, the smallest number is going in the node. Okay, so we've got 5 there. We've got 5 subtract 2. Which is a 3, and there's only the one option, so 3 is going in the right-hand side. We've got 10 take away 8 is 2, or we've got 9 take away 3, which is 6. And remember, apologies, 10 take away 4 is 6. Okay, so that should be a 6 there. So we'll make that a 6. Okay, so 10 take away 4 is 6, or 9 take away 3 is 6. So they're both the same number, so 6 goes in the node there. 3 take 3 is 0, or 6 take away 4 is 2. And remember, the smallest number is going in the node. So that is the backward scanning process done. Okay, so we go back to the original question. Okay, so the original question says, the owner believes this project can be completed in a minimal time with only 3 employees. Evaluate the reasonableness of this belief. Okay, as you can see, it's a 7-mark question. Okay, so first of all, completing the network. Okay, completing the network, that's going to get us 1 mark. Okay, so there's 1 mark for completing the network. Determining the latest start time for every activity, which we've done with the red numbers there, that is going to get us another mark for completing the latest start times. For doing the earliest start time, so all of the blue numbers there on the left-hand side of each node, that is going to get us our 3rd mark, okay, out of these 7 marks. So in order to get the 4th mark, we've got to determine how many workers we're going to need, as well as the minimum completion time. So we know the minimum completion time. So what we'll do is we'll write here, minimum completion time is 14 days. So minimum completion time equals 14 days. Okay, so we've got 14 days, okay, for our minimum completion time. And that's going to get us another mark. So that's 4 marks so far out of our 7 marks. Now, in order to determine the number of workers that we're going to require, so because from the start there were 2 activities, activity A and activity B, okay, we only really need 2 workers to start off with. So what I've done is, on our next slide here, I've actually pre-prepared how many workers you're going to need. So as you can see here, to start off with, for the first worker, he's able to do, I'll just quickly shade these in. So the first worker is able to do activity A, which takes 3 days. He can then do activity C, which takes 2 days. Our worker 1 can then do activity E, which takes 5 days. He can then do activity H, which takes 1 day, and he can then do activity J, which takes 3 days. So worker 1 can actually do all of those activities in 14 days. So while worker 1 is doing those activities, we've got worker 2. He's able to do activity B, which takes 4 days. He can then do activity F, which takes another 4 days. However, while that's occurring, he's not able to do any other activities because, as you can see, activity G needs to start after 4 days. So we're going to require a 3rd worker. Okay, so he's going to do activity G. And then after his 3 days of doing activity G, he could also do activity I, which is another 2 days. But as you'll see at the top of the network, activity D goes for 8 days and finishes on the 14th day. So we're actually going to require a 4th worker in order to be able to complete activity D. So, question says, we'll go back here. Question says, the owner believes that the project can be completed in minimal time with only 3 employees. Evaluate the reasonableness of this belief. So according to our working, okay, 3 workers are not going to be sufficient. So we'll say here, 3 workers will not be sufficient because we're actually going to need 4 workers. So 3 workers will not be sufficient. 4 workers are required. So 4 workers are required. Therefore, the claim is incorrect. Now, in order to get those last 3 marks that we were chasing, so saying that the claim is incorrect, that is definitely going to get us 1 mark. Sorry. So that's going to be 1 mark for saying the claim is incorrect. Telling me that there's 4 workers, okay, that's going to be required. That's going to be another mark. And then there's going to be another mark, which a lot of people often miss out on, for logical organisation of our work, which includes this diagram that we've got up the top here. So this diagram that I've constructed up the top, that will also be worth 1 mark for setting that out there. And that will make a total of 7 marks, proving that the claim is incorrect.